Hi, folks. In this section, section 10.4, we're going to talk about choosing a data display. There are lots of different data displays that you should know about. In this chapter, we've mostly focused on box and whisker plots as well as histograms. However, you should be familiar with other types of graphs from other math classes. And so I've just kind of given you this summary data table on the back of your notes so you can refer to it if necessary. We've certainly done scatter plots in Algebra 1, but some of these other ones you've hopefully learned in other classes. We are going to talk about circle graphs today um, and how to draw those, but some of these you're expected to know from previous examples. One of the important factors that goes into choosing what kind of graph to draw is the type of data that you're given in a problem. And the two main categories of data are qualitative versus quantitative data. Qualitative data, you hear that word quality in it, measures some sort of quality. It's some sort of label like colors or months of the year, something that is not numeric. Quantitative data, on the other hand, hopefully you hear that word quantity, quantitative data, you hear that word quantity in there, does consist of numbers, some sort of measurements, or something that you've counted. And you use different types of graph depending on whether you have qualitative or quantitative data. And so the first step is being able to recognize and categorize the type of data that you have. So first of all, if we're talking about the prices of cars at a dealership, prices are numbers, and therefore this does count as quantitative data. Now, just because something's a number, it's only if it counts as a number that we call it quantitative. So, for instance, jersey numbers on a sports team. Jersey numbers are really just labels. Yes, they are numbers, but the number 5 on a sports team doesn't mean that that player is better than number 15 on a sports team. It's just kind of a label. So even though jersey numbers are numbers, the number part of that is not important. It's really just a label. So we do call this a qualitative measurement or qualitative value. It's not measurable. The lengths of songs at a concert, on the other hand, if you're talking about how many seconds long a song is, that is measurable. That is a quantitative measurement. Quantitative. And the zodiac signs of classmates, those are just labels. Are you a Gemini? Are you a Pisces? Whatever. Those are labels, not number values. So those are qualitative values. Okay. So quantitative data always need to be numeric. It can be a count or measurement, but qualitative data is usually non-numeric, but there are a couple of situations like jersey numbers on a sports team or maybe license plate numbers where you might have a number value, but it's really just a label. And so it's still qualitative. Okay, so what do we do with these data? Well, if we have something like an eye color survey, eye color, colors, that's qualitative data. And if you have qualitative data, the best graphs for your qualitative data are going to be circle graphs, which are also called pie charts, or bar charts. They can both be used to represent this data. I'm going to show you how to do kind of a circle graph step by step. Bar charts are easier to add to later. Like if you didn't think about all the possible eye colors, it's like, oh crud, I forgot hazel's an eye color. It's easier to add an extra bar to represent hazel later than it is to redraw your whole pie chart with a new slice of the pie that represents hazel. So you should use circle graphs only if you're fairly sure you've got all possible categories covered. Um, we're not going to suddenly discover somebody's got fluorescent purple eyes or something like that. So I'm fairly sure we've got an exhaustive list of eye colors here: brown, blue, hazel, green, gray, amber. And so I'm going to represent this in a pie chart. And we're going to look at how I know that my pie chart should kind of end up looking like this. What you do is you first add up the total number of, in this case, people surveyed. How many people were surveyed here? And if I add up 63, 37, 25, 10, 3, and 2, that all sums up to 140. So what I'm going to do now for each category is I'm going to take the number from that category, 63 for brown. I'm going to divide by 140, and then I'm going to multiply by 360. What I'm doing is I'm creating a fraction. 63 out of 140 people have brown eyes, but then I'm multiplying this by the number of degrees in a circle. And that's going to tell me how many degrees I should kind of measure out on my protractor as I'm drawing the pi wedge on my circle graph. So this is 162. So just not quite a straight line across a circle. That would be 180 degrees, would be half of a circle, but almost half of a circle for that value. For blue, if I do the same thing, divide by 140, but then multiply by 360, I get the value of 95 degrees. 90 degrees is a quarter of a circle, so I have just over a quarter of the circle representing blue-eyed people. For hazel, again, I'm dividing by 140, multiplying by 360, and that's going to be 64 degrees of the circle, are people with hazel eyes. With green eyes, that's 10 divided by 140 times 360 is 26 degrees. Gray eyes is 3 over 140 times 360, and that gives me 8 degrees. And lastly, 2 divided by 140 times 360 is 5 degrees. So you can use a protractor to measure angle measurements on your pie chart. So you can give each eye color a bigger or smaller wedge of the pie depending on what proportion of students have that particular eye color. Again, I could have shown this in a bar chart where I have different heights of bars on the graph. Brown would have the tallest bar, amber would have the shortest bar, uh, uh, based off of the number of respondents for each color. On the other hand, if I have quantitative data, especially what we focused on in this chapter has been quantitative data that shows the distribution of data within a population. That's when you use a box and whisker plot or a histogram. I have pre-put these in order for you to make it easier to do a box and whisker plot. So let's draw these as box and whisker plots like we did a couple of sections ago. Okay, so I've got highway A here and highway B here, kind of divided by the line. And I have 20 data points in each from each highway. And so my median is going to be between 68 and 68. So my quartile 2 value is going to be 68 for this one. And my quartile 1 and quartile 3, let me just make a table of data. I want to know my least, my quartile 1, my quartile 2, my quartile 3, and my greatest. We just said quartile 2 was 68. I know my least value is 59, and my greatest value is 82. And so what's my halfway point in column 1? It's going to be an average of those two numbers here. Quartile 1 is going to be 66, halfway between the 65 and 67. And same thing on this side. Quartile 3 is going to be halfway between 75 and 75, so that's just 75. Let's do the same over here for the second data table. My least value is 65. My greatest value is 84. Quartile 2 will be between 72 and 73, so that's going to be 72.5. Quartile 1 will be between 69 and 70, so that's 69.5. Quartile 3 will be between 79 and 79, so that's just going to be 79. And because I've done my 5-number summary for each interstate, I'm now ready to draw the box and whisker plot for each one. I'll do Highway A first with a low of 69, I'm sorry, 59, and a high of 82. Quartile 1 is 66. Quartile 3 is 75. So I'll draw my box there. And my median is 68. So that falls in about here. Attach my whiskers. And let's do the same thing for the blue interstate, Interstate B. My smallest value is 65. My greatest value is 84. Quartile 1 is 69.5, so that's round about here. And quartile 3 is at 79, so that's about here. Connect, draw a box between those two vertical lines, and then my mean is, I'm sorry, not my mean, my median is at 72.5, so that's around here. And connect those whiskers like this. So, in this example, I've now, because these data were quantitative, and because the Highway A and Highway B each represented a bunch of different measurements um, showing variation on Interstate A and showing variation on Interstate B, I chose to represent this as a box and whisker plot, although a histogram would have also been acceptable. A circle graph would not be acceptable because a circle graph is for qualitative data. Um, so we're using the display that best represents the data. And that reasoning, these are qualitative data that, I'm sorry, quantitative data that shows the distribution of a population for this second graph, whereas for this first graph, the pie chart, the circle graph, we had qualitative data. So that's why we chose that type of graph here. It's important to draw graphs that accurately reflect your data. It is possible to draw graphs that are misleading. And so here we have a couple of examples of misleading graphs, things that you should avoid doing. And we'll talk about what makes these misleading and why you should avoid doing it. First of all, your graphs should always have a title. They should have a key if it's necessary, like if different colors represent different things, you need to say what each color represents. Are the numbers of the scale evenly spaced? So, for instance, here, does each tick mark represent $500? You should be consistent with your scale. It's not a good graph if you aren't consistent with your scale. Does the scale start at 0? If it doesn't start at 0, is there a break? What I mean by a break is one of these kind of squiggles to show you that some values here were skipped. So here, for instance, this graph starts at 19,500. It does not start at 0. So there's no visual break to communicate to the reader, hey, this isn't starting at 0. So that is a problem with this graph here. The scale starts at 19,500, not 0. And there's no break to show that we didn't start at 0. Okay, so there's no break to kind of show that. The problem with doing that the problem with not providing a break is that this makes it look like the growth in kind of tuition is really, really fast. There's a big jump between each of those bars. In reality, the growth is only about $1,500 from the first year to the last year. So the growth is only $1,500 from the start to the end of the graph, but it looks bigger than that. It looks like it's large growth or fast growth. Okay. But you don't notice that because of the way that the y-axis is scaled. It's important to have all axes or sections of the graph labeled appropriately, and it's important for the components of the graph that are supposed to be the same size are the same size. So again, is the scaling on the y-axis equal? Or if you've got a histogram, is each bin of the histogram the same number of items? Like you go from 1 to 10 in the first column, 11 to 20 in the second column, 21 to 30 in the third column. You're not kind of putting 10 into the first column and then 5 into the next column and then 15 into the next column. Let's look at the second graph and see what's kind of wrong with it over time. Here we've got mean hourly wage for employees at a fast food restaurant. And you can see that I'm going up by 2 cents here, 2 cents, 2 cents, 2 cents, 2 cents. But look here, I'm now only going up by 1 cent. I'm going up by 1 cent, 1 cent, 1 cent, 1 cent. So I start going up by 2 cents and then I go up by 1 cent. Um, it's also kind of weird that I'm only going up kind of 1 cent at a time on the graph. This vertical scale is has unequal measurements or has unequal scaling. Okay. So if you look at this graph, it looks like the biggest increase is from 2018 to 2019. That's what it looks like, but that's not actually the case. The biggest jump is really between 2016 and 2017 when each kind of mark on the graph represented 2 cents. Um, it seems to be that that's the biggest jump, but the biggest increased or biggest jump is really 2016 to 2017. So that's why it's important to have even equal spacing on a graph so that other people interpret it correctly. So these are kind of all things to keep in mind when you're drawing graphs so that your graph communicates what you want it to. Once again, just to finish, looking at those different types of graphs that we've learned how to do in this class or that you should know how to do from other classes. Looking at the data, deciding if it's quantitative or qualitative, and choosing the right graph appropriately. I hope this helped.